All right, well, welcome everyone that's in person and folks joining us online. My name is Tracy. I'm the Education Director here at the Whale Museum, for those of you who don't know me. This is our last lecture of the summer, the season. So a really exciting topic, sea otters. I love sea otters. I love learning about them. For our in-person audience, there is bathrooms right by the gift shop when you first come in. That's always important to know. And is the temperature okay for you guys in here? Good. All right. Excellent. The upcoming events after this, stay tuned for more announcements. We will be planning a fall workshop. Tentatively, we're thinking November 13th for that. So that'll be an all-day virtual workshop. We have been talking about doing an open house too some point, maybe in the fall and winter time. So again, stay tuned for those details about that. And let's see, for our online audience, thank you so much for joining us as well. I do want to welcome everyone tonight. I'm so glad you guys all came out for this or are participating online for this lecture. And so my pleasure to introduce your presenter tonight. Dr. Shawn Larson received her PhD from the University of Washington School of Aquatic and Fisheries Science. Shawn is the Senior Conservation Research Manager at the Seattle Aquarium. Shawn has been working with sea otters for 30 years, focusing on sea otter reproduction, population genetics, diet characteristics, nearshore ecology, and most recently, the sea otter's role in mitigating climate change. She also leads the aquarium's wildlife rehabilitation response and oiled wildlife response planning. Dr. Larson has organized and run the Sea Otter Conservation Workshop in Seattle since 1999 and is the deputy chair and the Sea Otter Species Coordinator for the International Union for the Conservation of Nature Species Survival Commission's Otter Specialist Group. Wow, say that 10 times fast. Before Dr. Larson steps up, I do just want to give a shout out to Mike, who is our director, who's in the audience. I also want to thank Dante as well, for board member, for helping us live stream. All right, and with that, I want to give the floor to Dr. Shawn Larson. Thank you so much for joining us and being with us tonight. Yep, make sure your mic's on. I'm going to turn mine off. They don't need to hear me.
Thank you, Tracy. Thank you, Max, for your applause there. So Max is my dog, and I didn't have a dog sitter, so Max is with us today, too. Yeah, Tracy told you who I am. I'm Shawn. I work for the Seattle Aquarium, and I run the research program, essentially. A little bit more about me, I always like to give a background. So I grew up in the Bay Area, and I studied at UC Berkeley as an undergraduate. I studied general biology. I thought I was going to be a veterinarian. Then I went on after I decided I'd rather work with healthy wildlife than sick animals. So I went ahead and received my master's at Cal Poly San Luis Obispo, and I studied big cats, which are a long ways from sea otters. My husband and I decided to move to Seattle at that time. And I volunteered at the Woodland Park Zoo, and I was working as a vet tech at the time because that was my experience. And then this job came up at the Seattle Aquarium. By that time, I had been volunteering at various zoos and aquarium and rehab centers for about 8 years. So I had some experience in that field, and then I had experience. I've been working as a vet tech for about 10 years by that time. And they wanted an animal health and research coordinator, and they weren't really ready for a PhD yet or a veterinarian. It was kind of, they were just starting their animal health program and research program. So they hired me and to start the research program, and then to interface with the contract zoo vets when we had a sick animal. And so I knew how to do both. But then to start a new research program was kind of daunting. I didn't have any funding. And I had to get small grants, and then I decided I really needed to up the game and continue my education. So I went back to school. I got my PhD at the University of Washington. I studied sea otters because that was the first animal that caught my eye at the Seattle Aquarium. They were kind of like sea cats, and they're just super fun to watch. And the Seattle Aquarium was the first aquarium in the world to successfully breed sea otters in human care. And so I wanted to figure out why. So why was the Seattle Aquarium so successful at breeding sea otters in human care? And so I started studying their reproductive physiology. And I did that non-invasively by collecting their poop, because sea otters eat a lot and they poop a lot. And I had poop from otters from all over the world, otters that were pregnant, non-pregnant, couldn't get pregnant, you know, all these different things, figured it all out. So that was my PhD. And then I also studied genetics, because that's another part of reproduction. At any rate, fast forward, I've been there 30 years now. It seems amazing to me, and I thought I was just going to stay for a couple of years and then go back to the zoo world. But they were paying me to scuba dive. They were paying me to watch sea otters, and there was so much to learn, and I still love it. And now I oversee a research team of 6 people, and we have many, many projects, from 6-gill sharks to marine debris to rockfish to Hawaii fish to kelp recovery, and of course sea otters. So Seattle Aquarium, for those of you that don't know, it sits right on Seattle's waterfront. So it's right in the middle of the city, right in the heart of the city on the waterfront. We're actually on piers, so we're over the water. And you can see there's a big wheel behind us, and we've got both of those stadiums that cost way too much money, but you know, go Mariners. So at any rate, we're right there in the thick of things. And this is one of our exhibits, or habitats we call them now, and it's really a mixed species habitat, and it's big enough for divers to go in, and they talk to the audience and they tell them about all the animals that are in this exhibit. And these are all temperate waterfish, so they're rockfish and lingcod and cabezon and salmon and things like that, and they talk about the ecosystem and how they all live together. One of our stars is a giant Pacific octopus, of course. They're beautiful, amazing animals. And then we have another mixed species tank, the Underwater Dome, which was really iconic when it was first built in 1977. This was the first aquarium that had a space where you could walk under the water and look all around. And of course we have marine mammals, and we have harbor seals and fur seals, and then the sea otters. So that's just a little bit about the Seattle Aquarium where I work. And let's get to the otters. There are 2 species of otters in North America. There are 14 in the world. We have 2 of them here in North America, and they are the sea otters. The sea otter is to your left, and the river otters are to your right. We live in the Salish Sea. We're surrounded by salt water, and you'll a lot of times see an otter in the salt water, and a lot of people think that's a sea otter, but it's most likely a river otter. So a lot of people tell me, oh yeah, I have a sea otter living on my boat. And I'm like, I don't think you do. It's probably a river otter, and there's a lot of differences. Sea otters are 4 to 5 times bigger than river otters. So river otters are about 20, 25 pounds. Sea otters in Washington get up to over 100 pounds, and they're 5 feet long. Sea otters primarily float on their back when they're resting. River otters, when they're resting, go to land. So sea otters spend most of their time in the water. River otters will go into the water to forage and to play, but they'll come back on land to rest and do everything else. So the sea otters are true marine mammals. They never have to come to land to do any of their life history characteristics. To sleep, to eat, to breed, they can do everything in the salt water. And that's not to say they don't sometimes come on land. They do. Sometimes they will haul out. We don't know why, to rest or whatever, but a lot of times they're in the water 24/7. And their diets are different. So sea otters eat primarily benthic invertebrates, and because of that, they have very different dentition or teeth. They have crushing molars in the back of their skulls, just like people. So they have the canines in front, but in the back they're flat for crushing shells. River otters have teeth like your cats and dogs. They're all pointy and cutting because they're mostly eating fish, and they're cutting flesh out of the fish. So very different. Whenever somebody shows me an otter skull, I can immediately tell if it's a sea otter because they look very similar to humans. A little bit of background. This is a beautiful raft of some male sea otters here in Washington State. sea otters are social, extremely social. They form large groups called rafts. You'll rarely see a sea otter by itself. If you do see a sea otter by itself, it's likely a territorial male, and he's not too far from his girls. So sometimes I'll go out on the Washington coast and I'll see this huge sea otter, over 100 pounds, and I just wonder where his girls are. And if I look long enough, I will find a raft of females. They sexually segregate except for those territorial males. So there'll be groups of females with pups. There'll be 1 or 2 territorial males that are always nearby, but then those groups of bachelor males are to the edges of the sea otter range. They're pushed to the side and kept separate. This may change when sea otters fully recover, because right now sea otters haven't fully recovered from near extinction, and so there are edges of the range, right? And we're just wondering what's going to happen when all those edges of the range fill in. Then where are those bachelor groups going to go? So it may totally change the behavior that we're seeing now, which is kind of cool. There's a lot of things we don't know. They're sexually mature by age 2, and the reproductive rate is high. So females that are sexually mature, 80 to 90% of them have a pup every year. And the females are pregnant for 6 years, and then they take care of a pup for 6 years. So they're either pregnant or taking care of a pup their whole adult lives. That's a lot. They live to be 15 in the wild and longer in captivity. The Seattle Aquarium has one of the longevity records. One of our sea otters lived to be over 22 years old. So, and they are a true marine mammal. Sure. 6 months. Did I say 6 years? I'm sorry. Yeah, sorry. They give birth every year. Thank you for correcting me. And they're, yeah, pregnant. No, I want you to understand. They're pregnant for 6 months. Then they're taking care of a pup. For 6 months, once they wean that pup, they become pregnant again and they start the cycle again. So the females are usually very energy limited. Yeah, sorry. Yeah, I misspoke. So they live in North Pacific waters, and they're one of the only marine mammals that don't have a blubber layer to stay warm. So how do they stay warm? And this picture should give you a little bit of a clue. They're fuzzy. They're super fuzzy. They have one of the densest fur in the animal kingdom. In a square inch, which is about this big, 500,000 to 1 million hairs per square inch. So their fur is so dense that the water never touches their bodies. And in fact, they groom a layer of air next to their skin. So this is a little dry suit that they create while they're floating in the North Pacific waters. Their internal temperature is the same as a cat or a dog, about 100 degrees. So even though they are floating around in a little dry suit, and in fact, they dive to collect their food because they're eating invertebrates on the bottom of the ocean. When they're diving, that air is squeezed out of their fur and they leave a bubble trail. They have to stop and groom that air back into their fur about every 20 dives. So they're constantly maintaining this thermal regulatory system that they have. But they're floating around in a dry suit. Anybody who's a dry suit diver knows that you still get cold. So they have this incredible internal engine, and they have one of the highest caloric demands of a mammal their size. So they have a really high metabolic rate. They eat 25 to 30% of their body weight every day just to maintain their body condition. And those males in Washington are 100 pounds. So they're eating 20 to 30 pounds of shellfish meat, not the shells, of meat every day just to stay alive. And the females, when they're pregnant and lactating, they're going to have to eat even more. So these guys, they're right on the edge of the thermal capability to live in the North Pacific with this system. A lot of times I feel, just get a little fat, get a blubber layer, and it'll be much easier like a seal. But it's pretty incredible. And it's because of this incredibly thick fur that sea otters have interacted with humans for as long as humans have been in North America. So we think that indigenous people came to North America about 10,000 years ago, and since they came to the North Pacific, there are stories about sea otters, and they would hunt them for their fur, and the fur was highly prized, and only the highest, the people in the highest levels of the tribe were allowed to have sea otter furs. They were very ceremonial, and then they would use the furs to trade for other goods with neighboring tribes, because they're, especially the inland tribes that didn't have access to sea otter furs, they were really valuable. And these were some of the things that they first traded when Lewis and Clark came over. They would trade them sea otter furs. So sea otters and humans have a long history. And it wasn't until the Europeans and the Russians and the Asian people found out about this incredible fur. The sea otters were relatively safe. But when the rest of the world found out about it in about 1740, after the Bering expedition returned from the North Pacific to the Orient and Russia, this started the fur trade, the maritime fur trade, from the mid-1700s until 1910. And this is a map. The brown is the original sea otter range. And you can see sea otters have originally ranged throughout the North Pacific, from Japan all the way through the North Pacific, all along the Aleutian Islands, along the west coast of North America, down to Baja. We think there were about 300,000 sea otters at that time before the fur trade, but nobody knows really, because they weren't doing regular surveys like we try to do now. At any rate, after the end of the fur trade, the only sea otters left were those indicated by the red, orange-red dots. So there were about 11 populations left, scattered mostly throughout the Aleutian Islands, the Kuril Islands, and Russia, with a little population in Prince William Sound there at the top in the Gulf of Alaska, and then a little tiny population in the middle of Big Sur, California. And we think the only reason why these survived the fur trade is because there were super remote areas, really rocky, rough areas that the ships that hunted them couldn't get in and find them. And so it's because of these remnant populations that we actually have sea otters today. But we almost lost them. The last Washington sea otter was shot for its fur in 1910 in Willapa Bay, the last native Washington sea otter. So this is what the range of the sea otter looks like today. So that gray-brown is the remnant populations that have recovered over time. So they were protected in 1910 under the International Fur Seal Treaty that also protected sea otters. Since then, there have been other protections like the Marine Mammal Protection Act, like the Endangered Species Act, and sea otters were not hunted for their fur for about 100 years. And they recovered pretty well, except for there still were no otters between Prince William Sound and Central California. But then there's that yellow range there, and those are the result of successful translocations that occurred in the 1960s and 1970s. And those animals were taken from Chitka Island in the Aleutian Island chain, as well as Prince William Sound. And it's because of those translocations to Southeast Alaska, to British Columbia, and to Washington that we have sea otters in those areas today. And they account for 1/3 of the sea otters alive today. So the translocations do work. There's still a large gap in their range where they used to be between Central Washington and Central California. So Oregon doesn't have any sea otters, Northern California doesn't have any sea otters. Actually, Southern Washington doesn't have any sea otters either. Today, the total number of sea otters is about 120,000. And so we think that sea otters are about halfway recovered from the fur trade. And even in those areas where sea otters occur, they're still not in all the habitats where they originally were. So they still are absent from many bays and estuaries. And most of the sea otters we find today are in rocky outer coast systems. They're not in bays and estuaries. And we know, for example, San Francisco Bay, they estimated had 10,000 sea otters before the fur trade. So bays and estuaries can definitely have a lot of sea otters. So why do we care about recovering sea otters? I mean, yeah, they're cute. It's nice to have a success story to recover a population or a species that we almost hunted to extinction, but there's another reason. And the reason is that they are a keystone species. And does anybody remember dictionaries? Remember dictionaries like Wikipedia? So in the dictionary, If you look up keystone species, there's likely a picture of a sea otter. They are an iconic keystone species. What is a keystone species? Well, a keystone is that stone in an arch that holds the whole thing together. So sea otters hold their nearshore ecosystem together. And we learned this from that massive exclusion experiment or removal experiment that was the fur trade. It was an unintended experiment, but it was an experiment. They removed a bunch of animals, and then as they recovered, they could see over and over and over again what happened to the nearshore as these animals recovered. So in islands in the Aleutians, which is where they first documented this, the islands that had sea otters in them had healthy kelp forest ecosystems. They had all sorts of different algae, they had canopy-forming kelps, they had fishes, they had birds, they had mammals, they had the whole kelp forest ecosystem. Right next door, in areas without sea otters, there was no kelp forest ecosystem, it was an urchin barren. And what happened was the urchins, without any top-down control, it's called a trophic cascade, if the urchins aren't controlled, then they wipe out. They basically scour the benthos. They're very voracious eaters as well, and they'll eat all the algae first, and then after they're done with that, they'll eat sponges, and they basically just remove everything on the seafloor. But with sea otters, with that top-down control, because sea otters like to eat, they limit the number of urchins. There's still urchins in areas of sea otters, but they're not a monoculture. They don't overtake everything. In areas with sea otters, you have healthy kelp forest ecosystems. They're more biodiverse. There's more primary productivity. There's more habitat for and food for the other invertebrates, for fishes, for birds, for marine mammals. And then without, you have this urchin barren. And this has been documented over and over and over again. So this is a graph of what the urchin catch looks like. So an area where sea otters move in, and let's say there's an urchin fishery. So you can see right when the sea otters move in, the urchins are relatively high, but over time, when the density of sea otters increase, so from 0 to 22 sea otters per kilometer, the urchins are still there, but they're held at a really low density, and they're found in crevices and things like that. And the urchins are actually healthier because the urchins have all that kelp to eat, right? But with that, with the decrease in commercial like urchin fishery, you have an increase in kelps, and then there's going to be an increase in fish fishery because the kelp provides food and habitat for a whole suite of species. This has been documented over and over again. This is data from British Columbia. Just as said, the areas with no otters are to the left. After 5 years, you can see what happens after 20 years. Basically, on the top, the canopy-forming kelps, the giant kelps and the bull kelps just dramatically increase. Then there's understory kelps that also increase. There's a little bit there's a little hump in there. I don't have a pointer, but as the sea otters do start to increase, some of the kelps will have a spike, but then they'll come back down, but the level will be higher than without the sea otters. And that's because the sea otters are providing food for all those other invertebrates that do like to eat kelp too. So sea otters are basically promoting a biodiverse system. Again, no otters to the left, otters after 20 years. The fish dramatically increase in numbers and size. The crabs, which sea otters also like to eat, increase in size. The snails, which the otters like to eat, increase in size, and then the kelp. And this is, again, because it's just that the sea otters are providing the food and habitat for everybody else. Pretty cool. Another graphic, they found this where without sea otters, there are lots of urchins, and the kelp was restricted to a very narrow area. After sea otters, the kelp is deeper and has more area, and then there's a lot more fish. And this change they found in Haida Gwaii in British Columbia happened within 1 year. So this is quick.
Is it because they're eating the urchins?
It's because they're eating the things that limit the kelp, exactly. And that's the trophic cascade. You bring otters in, they eat the urchins first, that allows the seagrasses and the kelps and the understory kelps to recover, and now there's a lot more food for everything else, for those other invertebrates that like to eat kelp and algae, and then the fish move in because they like to eat the things that eat the kelp and the algae, and it's just a more productive, biodiverse. The sea otters are providing just their presence, and it's because they eat so much too. They are providing their ecosystem service as the keystone species, and this is what we talk about, recovering complete ecosystems with those top predators. A lot, you don't realize what the ecosystem service is that they provide until you have areas where they aren't there, and then you can see the difference. This is what Bob Payne did out on the outer coast. He removed sea stars from tide pools, and he would just remove the sea stars and see what happened. And all of a sudden, those tide pools became less diverse, and they had just one species in them. But with the sea stars, there were multiple species. So this is not just unique to sea otters, but it happens in a lot of systems where you have a keystone species. As sea otters have recovered, we've seen this not only in kelp forest communities, which are where they first recovered, those outer rocky coast systems, but as they've moved into more estuaries and bays, we've seen this happen in eelgrass communities. This is from Elkhorn Slough in California. The sea otters move into the estuary, they eat crabs. The crabs were limiting snails and slugs that were cleaning the eelgrass so they could photosynthesize better. So the sea otters move in, remove crabs, and all of a sudden the eelgrass bed is thicker, more diverse, and just like, what, why do we have such great eelgrass here? And eelgrass is a wonderful habitat for baby salmon and other baby fish. And it was dramatic what happened after the sea otters moved in. The eelgrass just increased in density and area. They've found it in salt marshes too. It's the same thing. The sea otters come in, they eat the crabs that were burrowing in the salt marsh and making it more easily eroded by flash floods and things like that, by flooding. When the sea otters moved in, they removed those crabs that were making all those holes, making the seagrass more stable, the salt marshes, and now there's dramatically less erosion in those areas. So with climate change, with more dramatic floodings in these areas, the sea otters are stabilizing it. And we're seeing that in many systems now. And sea otters are only halfway recovered. So just think what we might learn about their role in other ecosystems as they recover. So I'm a big fan of sea otters in the ecosystem because of that keystone species role. But what does the aquarium do to help conserve sea otters? We've done a lot of in situ research. So I've done the endocrinology, figuring out how sea otters breed, and then I've done some genetics work. We're right now still monitoring their population trends, and we look at their diet. So really quickly, want to dive into a little bit about the genetics. This is for my PhD, published a bunch of papers. What we found was, well, first of all, my interest was this fur trade. 99% of the sea otters were removed for their fur. What happens if we remove 99% of the people in this room? We would see a lot less diversity, right? We would see maybe people with just one color hair or whatever, one color eyes. So when you remove 99% of the animals, what happened to their genetic diversity? And that's what I wanted to find out. So I got sea otter samples from all throughout the range from modern sea otters, and then I got some pre-fur trade sea otter genetic samples from otters that had been dead 600 to 10,000 years. So how do I get DNA from otters that are extinct, right? This was a fun one. What I did is I went to the Macaw tribe because I knew they had a village that had been wiped out by a mudslide 600 years ago, and they went through and they curated all of the artifacts, so baskets, all these other things, but also what was in their midden remains, what was in their basically trash heap. And they had fur seal bones, they had orca bones, they had gray whale bones, they had sea otter bones. So they had a bunch of sea otter bones that were 600 years old. I asked them if I could take a sample, and I turned it into bone dust, and I extracted those old sea otter DNA to see what it looked like before people had removed 99% of the otters. And I did that for pre-fur trade otters from California, Alaska, all throughout. What I found was modern sea otter populations have about 47-50% genetic diversity, and that just means that in their genes, everybody has 2 copies of their genes, one from mom and one from dad. 50% of those genes had a different copy, and 50% had the same copy. So it's only 50% diversity, right? Humans, dogs, cats, animals that haven't been hunted extensively have about 80% genetic diversity. So 80% of our genomes, we have a different copy from mom and dad, which is great because if mom's copy of the gene doesn't work for us, dad's may, right? And to combat this disease or to deal with whatever's happening. So greater genetic diversity is always a good thing. It's called genetic plasticity. So poor sea otters today have pretty low genetic diversity. What did they have before the fur trade? They had 80%, almost 80%. So sea otters didn't always have that low genetic diversity. So how do we increase genetic diversity? Well, it's mutation, and that takes a long time. But since sea otters are still recovering, and they have this area where there aren't any sea otters yet, and especially in the 60s when they did those translocations, luckily they moved sea otters from different populations and combined them. So they moved otters from Amchitka Island and Prince William Sound and combined them in Southeast Alaska and British Columbia. So they took 2 different source populations, combined them, and now those populations have higher genetic diversity. Washington was founded by just Amchitka otters, but since Washington's population has grown and British Columbia's population has grown over the 50 years since they were translocated, they've started to merge. And so now Washington has higher genetic diversity because the Vancouver Island had different genes that Washington didn't have. So it's really those translocation of mixed groups that can recover genetic diversity the quickest, and that's what we're hoping for in the future. The Seattle Aquarium monitors the wild Washington sea otters.
Can I ask a question?
Sure.
And I don't know much about genetic diversity and species and stuff. So all those different areas, are all the otters of the same species? There are different.
Yes, so sea otters are one species. There's 3 subspecies that I won't get into.
So they can all interbreed?
Yes, yeah.
So it's just
Yeah, one species.
they're like all around the world, it's the same species?
No. Sea otters. So there's 14 species of otters in the world. Sea otters are one of the species, but sea otters are not divided into different species. So there's Russian sea otters that are in Russia and Kuril, and there's the Alaskan sea otters, and then there's the southern sea otter, and they're designated as subspecies or races because of skull morphology. I'm working on a genetic definition of the sea otter subspecies, and I don't think there's that much difference.
But they will interbreed, so they can take all the different ones and find them.
Oh, absolutely. The sea otters don't care if they're from Russia or Alaska or California. Yeah. Absolutely. So getting into the Washington sea otters, again, the last native Washington sea otter was hunted for its fur in 1910 in Willapa Bay, and that hunter received $1,000 for that one fur at that time, and that was enough to buy a house. So these furs were, this is why sea otters were almost wiped off the face of the earth, because they were so valuable. Almost 60 years later, sea otters were reintroduced from Amchitka, 29 near Point Grenville, which is off of the Quinault Nation, and 30 near La Push. The first translocation in 1969 was deemed a failure because most of those animals were wash ashore dead shortly afterwards, because they basically were captured in Amchitka, put in crates, flown to Washington, and not fed or anything, and then just dumped into the water, and they were very stressed, didn't do well. Then the 30 near La Push, they actually put them in net pens for 3 days and fed them before they released them, and those guys did much better. A lot of them still died, but we think about 10 animals founded the population we have today. Again, here's how far they had to go from Amchitka all the way to Washington. That's a long ways, especially in the 60s when, they didn't have super jets then. So we monitor them with the federal government and with the state and with the tribes in the annual population survey. It's a multi-day count from the ground and the air. We're one of the ground counters. This started in 1989 when there were less than 100 animals counted in Washington. We started joining the annual survey in 2000. And basically, there's a plane that flies the whole outer Washington coast, sees a group of sea otters, circles the group, takes pictures from the plane, but they miss a lot of them, so we have ground counters scattered around, and we have high-powered spotting scopes, and we get a finer count. There's 20 individuals or 200, and there's, you know, this many pups, and then there's isolated individuals that maybe the plane wouldn't get. Yeah, so that's how we do it. The plane typically flies from Olympia. We'll go out to the coast, fly the whole coastline, and even into the strait, and then come back, refuel, and do it again. If we have good weather, we get, you know, up to 6 counts, because they do 2 flights a day. If we don't have good weather, we take what we can get, and it's the highest count. And this is what it looks like over the years. So about 100 animals in 1989, and throughout the years, it's been steadily increasing at about 10% per year. There's a couple of years that we missed, 2009 because of weather, and 2019, I forget why, I think it was lack of funding, and then 2020 for obvious reasons. And, but there's been a little bit of variability the last 5 years, so we were on this trajectory of 10% growth pretty regularly, and then it's been going up and down and up and down and up and down, and we think we know why. It's growing pains. And I should go back. There are about 3,000 sea otters off the Washington coast today based on the survey. I think there are more, but there's about 3,000. And it's growing pains. And so the sea otters range from Nia Bay all the way down to Point Grenville. So it's the top third of Washington, or maybe the top half. But since the mid 1990s, they've been moving from central Washington to the southern part. So it used to be most of the otters were north of La Push. Now most of the otters are south of La Push. So they started moving south. And then most recently, in like 2022, they started moving offshore. So if the plane doesn't do an offshore run, instead of just hugging the coast, they're missing a whole lot of sea otters. And so not every time when we got those low counts, it was because they didn't do an offshore run. So now they're starting to learn we always have to do an offshore run. And those sea otters are so far offshore that the ground counters can't see them, because our spotting scopes can only see about a mile offshore. And we think that these floating rafts offshore are about 5 miles offshore. And they can do really well out there because sea otters can dive to about 200 feet. And we have a very long sloping continental shelf on the outer Washington coast. So they can go out quite a few miles and still be able to dive and get their food. And they've recently expanded into the east. Now there's a group of wonderful young, newly weaned, primarily males, off of Clallam Bay CQ, and they are hilarious. And they don't know what they're doing, and they have a couple of older guys that are kind of chaperones, but they just bring up everything from the bottom, whether, you know, a piece of kelp, I can't eat that, a gumboot chitin, I don't think I really want that, and then a huge urchin, and then they don't really know what to do with it, but then they figure it out, and crabs and clams and everything, so there's plenty of food for them there, and then they just play all day long. It's kind of ridiculous. It's really fun to watch. So if you're in the CQ Clallam Bay area, look for a raft of otters right in the middle of that bay. There'll be a lot of splashing. You can't miss them. So besides looking for, you know, how many otters and where they're at, we do sea otter diet surveys. We've been doing this for 15 years, and we're going throughout the sea otter range. We have 25 spots that we go to. But we're looking at what the sea otters are eating in the north end, in the central area, and in the south end. And this is important for a number of reasons because, again, they have high caloric needs. We're tracking their dive time, which gives us an indication of how many calories they're burning. We're tracking their surface time, which is the time they're on the surface floating on their back. And they're showing us what they're eating because they're floating on their back, and they'll almost hold it up for us to see. And we determine what prey it is as best we can. Is it a clam? Is it a crab? Is it a mussel? Sometimes they bring up giant Pacific octopus. And then how big is that prey item relative to their paw size? Because that's kind of our measurement. That's our ruler, is their paw size. And this is goes into this database that is backed up by tens of thousands of dives that people have collected in Alaska on sea otter diet and California. And this is one of the first times that we've collected a lot of sea otter diet data in Washington. And this is important because it not only tells us how well that individual otter is doing on getting the amount of calories it needs, it tells us how diverse the benthos in Washington is, where that otter is diving, and it tells us whether or not the population is reaching carrying capacity or not, or equilibrium, based on the kilocalories per minute that they consume. And again, this is based on data from populations at carrying capacity in California and Alaska, as well as other areas. So we know how many kilocalories typically a population that is still has plenty of room to grow would consume versus those that have been there a long time and are at their capacity, essentially. And this is what it looks like. So this is a female sea otter with her pup. She's eating a little crab, and they eat it pretty fast. So you have to get your scope on there and go, okay, how big is that crab? I think it's a crab, and how big is it relative for her paw size? And it's great if she has a little pup like that, because she'll go underwater. We have to find her again, but if there's a pup floating on the surface, she'll pop up right next to that pup. So we call this our sea otter buoy. So yeah, and now she's gonna go dive, so we'll have our little timer, and we'll time her dive, and we'll time her surface time, what she's eating, how many, and then the size of it. And here she's eating mussels, and she's got a large pup, and that little guy is trying to steal her mussels, or she's gonna share it with him. But yeah, so this is what it looks like. It's really fun. It's really fun to watch these guys. All of this goes into a really fancy model that Tim Tinker created. We commissioned him to create. He's much smarter than I am. It's based by a Bayesian model. And again, it's backed up by tens of thousands of dives and also bomb calories of all the sea otter prey. So we know if a sea otter brings up a clam that is 3 paw widths, it has this many calories in it. And so that's why we determine, what prey it is and what size it is. And then Monterey Bay Aquarium actually put some sea otters that were very good sea otters in a tank and put those oxygen domes over them to test their metabolism based on the amount of time they were underwater. So we have dive time and how many calories they burn, and then we have the prey and how many calories are in that prey. And it all goes into this model that's really fancy, and it tells us how the population is doing. And this is how Washington is doing. This is what it looks like. And it tells you what they're eating. The most of what sea otters in Washington are eating are crabs. They're eating urchins on the top, clams, mussels, a bunch of different crabs, cancer crabs, kelp crabs, unknown crab, snails, and then other hard substrate that we don't really know. But the vast majority of what Washington otters are eating are crabs. Energy intake. So I want to note this. So these are the crabs. We're looking at 15 to 20 kilocalories per minute. The ones down here, the clams even are 10 kilocalories per minute. And then the snails are about 10. Sea otter populations that are at carrying capacity typically, regularly will be in the range of 5 to 7 kilocalories per minute. These guys, it's unheard of almost to see that 20 kilocalories per minute. They have a long way to go before they get to equilibrium or carrying capacity. These guys have plenty of rich food. So the outer coast of Washington is very productive. And
Do they go after the crabs predominantly because they're easier prey, or is it because they're more nutrient dense?
I think sea otters are opportunists, and so I think that there's a lot of crabs in the Washington coast. Yeah. So new research we like to do was motivated by this paper in Science that says keystone predators govern the pathway and pace of climate impacts in the subarctic marine ecosystem, basically in the Aleutian Islands. What they did is hypothesize that in the face of climate change, if there were sea otters would slow the pace of urchins devouring kelp and also other algae. So they didn't actually have any sea otter data. They just speculated that in oceans that are warming and more acidic, sea otters could slow the destruction of urchins. I actually have some data. So I do dive surveys out in the outer Neah Bay area. After the warm water blob of 2014-15 and after sea star wasting in all my dive sites, that green arrow is just showing the dramatic decrease in algae in 4 sites, but not on the bottom. The bottom stayed the same. And then this is the increase in urchins after 2015 here. This was the warm water blob. This was sea star wasting. The urchins exploded on these areas in sites R1 through 4, but not site 5. So what's different between site 5? Site 1 doesn't have any sea otters. And you can see before the sea star wasting and the warm water blob, this is covered with a lot of fuzzy stuff. So it's got algae, it's got sponges, it's got sea stars. Fast forward after the warm water blob, after sea star wasting, it's scoured clean and it's an urchin barren. This other site is site 5, has sea otters. And the benthos didn't change. I mean, the picture on the left from the dive survey isn't great, but you can see there's algae, there's a lot of fuzzy stuff, there's a lot of invertebrates. Fast forward, and it hasn't changed at all. So oceans can warm, sea stars can waste, but with sea otters, the benthos doesn't change. The ecosystem doesn't change. And we saw that with a dramatic decrease in kelp after the warm water blob and sea star wasting in Northern California and Oregon. A lot of the kelp forests disappeared because they didn't have any keystone species. They had that intermediate keystone species, which was the sea star, the sunflower star. In Washington, the kelp forests on the outer Washington coast constricted and bounced right back. And we think it's because those sea otters stabilized the system. So here's sea otter density data from the macaw tribe that's shared with us. Here are my dive sites 1 through 4. There's a couple sea otters, you know, great. Site 5 has a much bigger circle. There's a lot more sea otters at site 5. That's the one that didn't change. So the sea otters are at ecologically functioning density at site 5. You can have 1 or 2 sea otters, but you have to have a certain number to have that ecological functioning, and it's about 6 to 7 sea otters per kilometer, which sites 1 through 4 don't have. We want to expand this dramatically. We really want to figure out what's happening on the outer Washington coast, and we're going to do this by employing our coastal climate resilience team that runs a small remotely operated vehicle, or ROV, with a Xbox controller, and it's really maneuverable. It has a bunch of cameras on it, and it gets great images of the benthos that then they put into machine learning, because they're gathering tens of thousands of images in every survey, and they can just gather tons of data, information about areas where kelp's doing well and versus where it's not. And they want to take this work that they've been doing in Puget Sound and bring it to the outer coast to really answer the question, how do sea otters affect coastal resilience in the face of climate change? And we hope that this will motivate reintroductions into Oregon and Northern California, which is already there. The Alaka Alliance already wants to bring sea otters back to Oregon, and they've been working for a while to do that. And then there's a new sea otter fund with the Wildlife Conservation Network that has pledged over $40 million over 8 years to bring sea otters back to the areas where they still don't occur through translocations. And we think that we can help this by actually answering that question about what's happening on the Washington coast, because what's happening on the Washington coast will likely happen on the Oregon coast once they bring otters back. So I won't get into this. It's all the cool stuff, but we really want to understand the mechanisms that are providing the resilience with the sea otter so it can be replicated. And those reintroductions, the argument is not so much for the sea otters and for connectivity and restoring them to their pre-fur trade levels. That's great, but that's for people who really like sea otters, right? It's really to restore ecosystem balance and resilience in the nearshore, which is what these complete ecosystems with keystone species like sea otters do. And with that, I just want to show you, I thought this was kelp. This is a place called North Rock, just near the Hoh River. Those are all sea otters. And when I zoomed in, I put my cell phone to the spotting scope, that's a raft of all sea otters. That's 700 sea otters in front of one rock in Washington every day, eating 25 to 30% of their body weight every day, and they do just fine. and the ecosystem does just fine. So, and I wrote a book on sea otter conservation because I really like them. 10 years ago, and it's all about the biology and ecology of sea otters, but recently, and I forgot to bring a copy, I just published a new book with a lot of other people. I was the editor along with Jim Bodkin and Aaron Foster and many contributors, but it's all about sea otters' role in ecosystem resilience, stability, and recovery. And I'm just in awe of these animals, really. So that's all I have. Hey, Maxie, good boy. Good boy.
If you're going to ask questions, if you can repeat the question in the mic for our online audience, that
Sure.
would be great. Yeah.
Given the abundance of food, what factors can you tell us as limiting the rate of recovery, the rate of expansion? And what colors my question is, when you smoke it here in Single Island, you see more sea urchins than you can count. So they're welcome.
So sea otter range expansion is really slow, and the sea otters also have very small home ranges. So males have 5 to 7 kilometers their whole lives, females like 5 to 20. They like to stay home, and they have plenty of food in Washington where they are. They don't need to move yet.
But excessive abundant food normally leads to an overproduction of offspring, which normally leads to
Well, they are limited to 1 pup a year. They have twins sometimes, but one of them doesn't survive. So they're not like, they don't have a litter. They're not like, river otters can give birth to multiple pups. Sea otters can only raise 1 pup a year. And half of the sea otters out there are males. So they are limited by their reproductive rate, and they're also, they don't expand their range until they have to. And they're just not, they're only 50% recovered. So when they get to fully recovering, they're going to move into other areas. But I have to say this, we don't think sea otters were very dense in the inland waters of Puget Sound and even in the Eastern Strait. And I say that because they're not found in the inland waterway indigenous people remains. And these were very prized pelts. And you start seeing sea otter bones when you get to Port Angeles and west. And I think it's just because Puget Sound is a pretty steep-sided fjord, and there's a narrow band where a large group like that 700 could live. There are 2 sea otters on the San Juans right now. There always are a few, but not at really big densities to knock down those urchins.
Yeah, you said they foraged up to 200 feet deep,
Yes.
and our water gets too quick.
And they don't like to go to, only certain males will go to 200 feet. They like to forage 60 feet and less.
But I was really, my question was going to be, for relocating populations, the blocks to that are financial, but also a willingness of areas to want to try to bring them back, because besides them being cute, you have to convince them that they could be good for that ecosystem to make it worth taxpayers.
Yeah, well, there's a lot of pushback from fishing communities because the fishers they learn that sea otters eat a lot, and they're like, well, they're going to eat all of our clams, they're going to eat all of our crabs, they're going to eat all the urchins, and there's a lot of pushback from that, and they've seen it in other areas. And what happens is the sea otters move in, and they do decrease the commercial numbers of those species, but over time, because they facilitate an ecosystem that's positive for those species, they recover, and they might be in slightly deeper water than the sea otter. So they tend to have to shift their fishery into deeper water, and people don't like to change. And so the fishers push back heavily. And I was at a sea otter community stakeholder meeting in Juneau, and the fishing community was upset because there's a lot of sea otters in Southeast Alaska. And this crab fisherman got up and he said, I've lost millions of dollars in my crab fishery. And then I walked by him at the coffee break, and he said, and I've made millions more in salmon fishery because the sea otters are providing more habitat. So, yeah. But That's the biggest political, socioeconomic pushback is the shellfish fishers. And you had a question in the back?
Oh, that was my question.
Oh, okay. It's financial too, because we got to monitor these guys before, during, and after. We're going to do it right because everybody has a phone now, and all the translocations before, some of the otters died, and boy, there's going to be a lot of bad PR if some otters die, and everybody. So why did you do this? Why did you move them? They were perfectly happy in Alaska and other places, but. We need to recover those animals for the ecosystem and to get the connectivity between the southern sea otters and the ones to the north, because Oregon actually was a hybrid area before the fur trade of southern sea otters and northern sea otters.
Just a comment, I learned that a lot of those relocations from Kamchatka were due to nuclear weapons testing.
Yes.
And they didn't want to kill a bunch of otters, so they moved them off the island. And even after that, they still killed like 1,000 otters anyway.
Yep.
Crazy reason.
Yeah. And it was so easy. They basically were going to test a nuclear weapon on Kamchatka, and the biologist said, "Wait, there's sea otters in Kamchatka, and there aren't otters in most of the west coast of North America. Let's move them before you do that." And so there was hardly any paperwork. Today, oh my gosh, the red tape. So yeah, those were very it wasn't fortuitous that we blew up Kamchatka, but the fact that there was foresight to move those animals is the reason why we have 30,000 sea otters in Southeast Alaska, in British Columbia, and Washington today.
So is the idea to move them over distance to create more genetic diversity as opposed to moving a population just a few miles?
Well, at that time, the Aleutian Island was or the Aleutians were populated, so they moved them, and then, so they were in the Aleutians, they were in central Alaska, they were in Prince William Sound, so they moved them to the areas just where there weren't already otters, which is great, because they could have just moved them like next door.
I'm thinking of it like now, so maybe it would be easier to transport, more likely to survive if you just move them miles.
Oh, they'll go right back home. No, they have a very strong homing. No, they tried that in Monterey. They moved almost 200 sea otters from Monterey to San Nicolas Island, which is 150 miles away. I don't know, maybe 200. And most of them swam back to Monterey. No, yeah.
Speaking of Monterey Bay, I'm familiar with that area, and at one time there was such a controversy over sea otters impacting the abalone fishery, and there was quite, a controversy over that. I don't know what happened with that. Are you familiar with?
Yeah, that's in my first book, that controversy. Basically, the abalone fishers, and they sued the state, and they had all these meetings and all this stuff, and the abalone fishers said there were no abalone because of sea otters, and then the biologist actually said, no, it's because of you. So the abalone divers were collecting something like 50 to 60 abalone a day, and they said, it's you, it's not the otters, so they eventually gave up. Yeah. Humans.
Unfortunately, I knew some humans that overfished it because of the price that they could get for it. It was quite,
Yeah.
lucrative.
Yes. Yeah.
Are sea otters able to give birth in the water?
Yes, they can't give birth on land. They're a marine mammal. And there was a question behind it?
Yeah, so based on all of the habitat monitoring, where do you think are the ideal locations for the next transit?
Yeah, that's a great question. The sea otters are doing really well in Elkhorn Slough, just outside of Monterey right now, because Monterey Bay Aquarium has been taking some of their rehab animals and placing them there, and over time, and it's protected, and there's plenty of food. So now Oregon is thinking maybe instead of dropping them on the outer coast, which we're not sure how they'll do, and there's sharks and other things. They're really thinking about bays and estuaries, and there's plenty of clams, and then just to give them a little, protection from waves and predators and all that, and let them establish themselves. And then eventually they'll move out. The otters will go where they want to go, but yeah, they're thinking of bays and estuaries.
You were talking about skull morphology earlier. What can you tell by the information through your spotting skull what a skull is, or is that something you find afterwards, like through technology?
Yeah, so I didn't do the skull morphology work. That was Wilson et al. In 1991, and they basically take it's a bunch of measurements they take on a skull that doesn't have any flesh on it, and then they put it into a multivariate analysis, and they say this population is different from that because of the way the skull is shaped, and skulls are shaped by a lot of things besides genetics, and it can be food availability and other things, and.
So it's not like looking at a German Shepherd, like it's not that.
No. Yeah. Sea otters, yeah. And there needs to be a genetic component with that, and we're working on it. Pardon me?
What's abalone?
What is abalone? Oh, well, it's a marine snail. We have them here, pinto abalone. They're gorgeous, and they're very endangered because people here over-harvested them, and they're one of those snails that eats kelp, but they broadcast spawn. So if the male is over here, and the sperm goes in the water, and the female's way over there, and if there aren't enough, basically they get to a density where they're so low that they can't effectively reproduce anymore. And that's what we think has happened to the pinto abalone here. But I don't know how many abalone species there are in the North Pacific, but I think, I'm not an abalone biologist, but there's at least 10. Yeah, and they used to be on almost every seafood menu in the 70s and 80s, abalone. They're tasty.
The Puget Sound restoration.
Yeah.
Really involved in
Abalone restoration. And kelp. Yeah.
So we have our few, like, individuals that live in the Salish Sea. Do you know if they're males or females, and then if so, are they breeding?
I don't know, but I would guess that they're males that don't mind being alone.
I know one is named Ollie, but
There was a female near Redondo Beach that was named Dumas because of the beach, but I remember I'm still at the aquarium. Anyway, so the state captured her because she was climbing onto kayaks and going up on the beach and joining picnics. She was very friendly, and some otters will do that. I mean, sea otters. But she's 70 pounds, so they didn't want her interacting with people, so they captured her, brought her to the aquarium. We held her overnight, got some blood and all that. She was gorgeous, just gorgeous animal. And then they took her out to Nia Bay and released her, and we didn't track her, so but there was at least one female in the sound. Yeah.
do you think the few that have been hanging out in the islands, if they were males, would those males be migrating at some point to find females?
I don't know the answer to that. We would have to, this is one of the issues with Washington is we don't have any tagged animals, so it's hard to track their movement. We're working on maybe doing some more tagging at some point. Where are you going, Max?
This is an exciting program. I'm curious, what's your primary source of funding?
For the aquarium? Our primary source is our gate. So 85% of our budget is from people paying to come to the aquarium to see our animals. The rest of it is through private donations and grants.
I spent a lot of time down in Elkhorn Slough watching the otters down there. A lot of females have bloody noses. Can you explain why they have bloody noses?
Yeah, so the males will grab the female's nose to keep her from leaving, keep her in place while they're breeding. And so in the process of that, will injure the nose, and so they'll have a bloody nose. That's a newly mated female will have a bloody nose, but I was just out on the Washington coast last week, and we saw a lot of what looks like pregnant females with nose scars. So big bellies, nose scar, oh, that's a female, plus it's a female known area. And then they have 2 pupping peaks. They can pup any time of year, but they have a peak in the spring and the fall. And so right now, September is a really great time. I saw a lot of females with newborn pups, like a week old, and they're just a little fluff ball on their chest. And then some females with very large pups. You guys are great. Lots of good questions. Take one more.
How do they eat the urchin? Those spikes and stuff, how do they actually?
Well, urchin tests aren't that strong, and so they grab onto it and they just crack it right open, and then they slurp up the uni.
And the spikes don't,
They don't seem to bother them at all.
because I've stepped on urchins.
Yeah.
That was one.
Sea otters are not deterred. One more?
Yeah, is the situation like a wolf pack with an alpha male and a lot of females, and then that other males fire it all away?
Yeah, but there's sneaker males that will come in too. But there's that territorial male that he keeps all the other males away from his group of girls. Yep, for sure.
All right, well, we want to thank you
Great,
so
thank
much
you.
for joining us tonight, and as a little gift, a little
Aw.
nudibranch pin.
Nudibranch. Oh, thank you.
Yeah. Yeah, that was great. We really appreciate you coming out tonight, and good turnout for you.
Yeah.
Yeah.
Wednesday night. Wow.
Yeah. So I already mentioned that we will be having a fall workshop and possibly an open house in the near future. One exciting thing that we just launched, I just want to let everyone know. I'm super excited about it. So we have just literally yesterday launched kits that can be loaned out for up to 2 weeks. And the kits are themed, marine themed. So we have cetaceans, which are whales, dolphins, porpoise kits. We have pinniped kit, which is seals and sea lions. We have salmon kits. So they're filled with specimens and lesson plans and activities. They're designed for youth up to high school. So if you have any educators in the audience here that might be interested in using those for youth, that is now a resource that we have that we will be allowing the community to access. Yeah.
Oh, that's pretty exciting.
And again, thank you everyone for coming out tonight and for joining us online. I want to wish everyone a nice and safe evening.
Thank you.
Can I have your